Hello student. In this lecture going to discuss the topic is shielding effect or screening constant. So it is a shielding effect or screening constant. So what is the meaning of shielding effect or screening constant? You all familiar with this. If there is a nucleus, around the nucleus there are number of orbitals, there is a number of shells are present. So nucleus is positively charged. The outer electrons or these electrons are attracted with the nucleus. So when the attraction is there between the outer electron and nucleus, this attraction is minimized, this attraction is decreases by the shell which are present between this outer electron and nucleus. So these two shells are present between the outer electron and nucleus. That's why this shell electron is less attracted due to presence of these orbitals, these shells. That shells behave or acts as a screen between the nucleus and outer electron. So here in a between shells there are different types of orbitals are present, s, p, d and f. So which type of orbital is here, that will shows the effect is shielded or de-shielded, more shielded or less shielded. So basically s orbital and p orbital shows stronger shielding effect. Suppose here is a 3d electron is there. So before 3d only 1s, 2s, 2p, 3s or 3p, these are the orbitals. That means only s and p electrons are exist between the nucleus and outer electron. So that time 3d electrons are more shielded due to presence of these inner shells. So this is nothing but it is a screening constant, or this is a shielding effect. So shielding effect depends on the presence of which type of electron between the electron to be considered or electron of our interest, which electron you taken for the interest, is it shielded or not. Between that you just see which type of orbitals are present, which type of electrons are present, and then you can easily say it is shielded or de-shielded. So this is the point. After that we are going to discuss here how to calculate the screening constant, how to calculate the screening constant. So here is the Slater rule is used. Slater rule is used. So according to Slater rule we can calculate screening constant. We can calculate screening constant. It is represented as a sigma. It represented as a sigma. So for that there are some rules are given. So first of all you understand the rules first, then you can easily calculate the any screening constant for any electron which is your interest, which is a part of your interest. Okay, so here we are going to discuss some. So basically if you want to your interest is in a s electron or p electron, your interest in d electron or f electron. So here we are going to discuss that if your interest is ns electron or np electron. So for ns np, before that we just see some common terms, common thing which is required. First of all your first rule is write electronic configuration. Write electronic configuration. Okay, then grouping of electronic configuration is second part. So then after that you make a groups. Suppose here is a 1s is first shell, in a second shell there is a 2s, 2p, in a third shell there is a 3s, 3p. Okay, 3d also from third shell, but for d orbital you make a different or special grouping. After 3d there is a 4s, then 4p, after that there is a 4f, then 5d. This way you make a grouping. You already know what is the sequence of electronic configuration according to above principle. If you not know, you try to write the electronic configuration, general electronic configuration up to 7s 7p. So using above principle you can write this. Okay, first of all you write general electronic configuration, means is their original electronic configuration, then make a grouping. Suppose I take here the Cl. Okay, there is a 17 is atomic number, so you write first electronic configuration is 1s2, 2s2, then 2p6, then 3s2, then 3p5, right? How you make a group here? For one first shell there is a 1s, second shell there is s and p, so 2s 2p, then there is a 3s 3p again from same shell, so 3s 3p. This way you make a groups. Okay, it is your second rule, make a grouping of orbitals. Okay, this is the second rule. It is common for any example, but after that what asking to calculate, then you decide the other rules, then that time you need some different rules. Okay, so first rule are common, write the electronic configuration, then grouping the electronic configuration. After that step third, so for shielding of n and ns and np electron, so here we consider ns np electrons. Okay, and for nd or nf, n is the nothing but the number of shell, or it is the principal quantum number. So you may have the two choices, or you maybe two different kind of electrons to ask to calculate their screening constant. ns np electron means electron from s or orbital or p orbital, or if you have to ask the d electron or f electron, that time you use different parameter. So when ns and np, the electrons other than interest, so all other remaining electrons which are present in ns and np shell, for that use 0.35 for 0.35 व्हॅल्यू. म्हणजे सपोज तुम्हाला विचारलं की 3p चा एक इलेक्ट्रॉन विचारला, कॅल्क्युलेट द स्क्रीनिंग कॉन्स्टंट ऑफ 3p. सो 3p मध्ये सपोज 5 इलेक्ट्रॉन्स असतील तर एकाचं काढायचं, मग रिमेनिंग किती झाले 4. सो 4 इंटू 30 0.35. सो ज्याचा विचारलंय त्याच्यामधले जे रिमेनिंग इलेक्ट्रॉन्स असतील त्या प्रत्येक रिमेनिंग इलेक्ट्रॉनसाठी त्या शेलमधल्या, सपोज इथं विचारलं 3s2 आणि 3p5 असे इलेक्ट्रॉनिक कन्फिगरेशन आहे, आणि इफ यू आस्क टू कॅल्क्युलेट द screening constant of 3p electron, so in a 3p you are going to calculate the screening constant of one electron. So how many remaining there? 4, plus in a third shell again 3s also present, so how many there are total? Remaining 4 and there is this 2, total 6. So you here going to 6 into 0.35. But suppose you have to ask the कॅल्क्युलेट द स्क्रीनिंग कॉन्स्टंट ओनली 1s. 1sचा ज्यावेळेस स्पेशल विचारतील त्यावेळेस तिथं ns ची व्हॅल्यू ही 1s असेल. सपोज 1s2 इलेक्ट्रॉनिक कन्फिगरेशन हेलियम, कॅल्क्युलेट द स्क्रीनिंग कॉन्स्टंट. सो फॉर रिमेनिंग इलेक्ट्रॉन you use 0.30 value. But other than 1s orbitals, if there is a s and p, ns other than 1s, they are all remaining ns and np, the remaining electrons you can use 0.35 value. Okay, it is a first rule, first condition. Second condition is for n minus 1 shell, okay, for n minus 1 shell you can use 0.85 value. How much? 0.85 value. Third, for n minus 2 shell, you can use 1.0 value. 1.0 value. How it? I just given here example. Okay, suppose we calculate the screening constant of chlorine. Okay, so first what is the electronic configuration of chlorine? 1s2, 2s2, 2p5, sorry 2p6, 3s2, 3p5, right? Then you make a grouping first here, 1s2, then 2s2, 2p6, then 3s2, 3p5. Okay, so you have to ask the screening constant of 3p electron. So what is your first rule? It is your ns and np, ns and np. So here you ask the calculate the screening constant of 3p, means you ask to calculate the electron from third shell. Third is the nth shell, right? So how many electrons are remaining in a third shell? This, there are total 7, but you have to ask 1, so remaining 6. So here first 6 into 0.35. Second, this is the nth. So before that it is a third shell, so second shell is n minus 1, first shell is n minus 2, because it is nth, n minus 1, n minus 2. So in a n minus 1, how many total electrons? 6 plus 8. So here 8 into 0.85. 8 into 0.85. n minus 2, there are how many? There are 2 electrons. So here 2 into 1.0. So make the calculation and do this summation. You getting the answer is the screening constant. So I just solve this example to understand the rules. Which electron asks to calculate the screening constant? Decide first, write the first two rule commonly. Then for ns or np electron, use this 0.35 for nth electrons, for n minus 1 0.85, for n minus 2 1.0. Suppose there is a n minus 3. So again after n minus 2, if remaining again all, suppose आता इथं थर्ड शेलचा विचारला आहे, तर n मायनस 2 सेकंड झाली, n मायनस 1, n मायनस 2 फर्स्ट झाली. पण तुम्हाला जर फिफ्थ शेलचा विचारला असता तर फोर्थ ही n मायनस 1 झाली, थर्ड ही n मायनस 2 झाली. मग आता n मायनस 3 का नाही? तर n मायनस 2 नंतर जेवढ्या पण शेल असतील त्यांच्या सगळ्यांसाठी 1च व्हॅल्यू घ्यायची इफ आस्क्ड दी फोर्थ शेल और फिफ्थ शेल. ओके, सो दिस इज द first condition when asked to ns or np electron. Then second is, if you have to ask nd or nf, for nd or nf electrons. Okay, so for that you must consider, first rule is write the electronic configuration, second is grouping of electronic configuration, then write the n remaining nd electron or nf electron. Okay, I will explain this with example. Suppose bromine is asked to you. Okay, so 35 is the atomic number of bromine, right? So you write first electronic configuration 1s2, 2s2, 2p6, then 3s2, 3p6, 4s2, okay, 3d10, 4p5. So 2 plus 8, 10, 18, 20, 30, 35 is the electronic configuration. Okay, so make here grouping first. How to make you group here? So this is the first shell 1s2. It is first rule, here is the second rule. Okay, then second shell, second cell, so 2s2, 2p6, then third shell 3s2, you write the s and p together, 3p6. Okay, so 3d you write specially, because d and f you can write a specially grouping. Then 4s here, then 4p5. Okay, this way you write. Suppose these electrons to the ask, you can neglect the remaining electron after it. त्याच्यानंतरचे जेवढे इलेक्ट्रॉन्स असतात, इथला जर विचारला तर हे निग्लेक्ट करायचे. हा विचारला तर इथून पुढचे जे राईट साइडला जेवढे इलेक्ट्रॉन्स असतात ते निग्लेक्ट करायचे. ओके, 3D विचारला तर 4s2 आणि 4p, देयर इज अ निग्लेक्ट. ओके, ते कन्सिडर करायचं. सो विच आस्क टू calculate the screening constant, then after that with the right side electrons, right side groups, you don't consider to calculate the screening constant. Okay, so here for nd and nf, so here if you consider this, and if you have to ask calculate the screening constant of 3d electron, then how many electrons here? 10 electrons. So you're going to calculate the for 1 electron, so how many remaining there? 9 electrons. So okay, first two rule, the rule is the remaining or the electrons in nd or nf, remaining electrons, consider the remaining electrons. Okay, used value 0.35, use the value 0.35. Okay, suppose you're going to calculate for this one, how many remaining? 9 is remaining. So here you do the 9 into 0.35. But in a NS and NP case, we use n minus 2 shell, n minus 1 shell. But here, remaining that the electrons which are present left side for all the electrons, for all remaining electrons, for all remaining electrons other than ND or NF at left side, consider value 1.0 for each electron, for each electron. This is a point very important, and you do some student do the mistake here. Which electron ask, and it is very easier. NS चा विचारलाय, NP चा विचारलाय तर रूल वेगळे आहेत, आणि D चा विचारला तर खूप सोपं आहे. डी मध्ये रिमेनिंग असतील त्याला 0.35 ने मल्टिप्लाय करायचं, आणि रिमेनिंग जेवढे असतील जस्ट काउंट द इलेक्ट्रॉन्स. पण असं नाही की हा विचारला 6 + 2 8, 8 and 8 16 to 18, 18 into 1 नाही करायचा, ग्रुपिंग वाईज 8 into 1, 8 into 1, 2 into 1, ग्रुपिंग वाईजच त्याचं लिहायचं आणि टोटल करायची. ओके, सपोज यू आस्क टू दिस वन. So what is the first rule? How to solve this one? The remaining electrons is, for remaining in 3D, how many there are? 9 into 0.35 plus, for all others which are present at the left, you consider the value 1.0. So here, how many? For in this group there is a 8 into 1, plus in this group 8 into 1, plus in this group 2 into 1. So total 3.30, 3 point near about 3.30 something, you do the calculation, plus 8 plus 8 plus 2, 10 18 19 20 21, so it may be 21.13. so it is a sigma is equal to 21.30. This way you can calculate. So any electron which is asked to any orbital which is asked to calculate the screening constant, you can easily solve these problems. So in online examination it is possible the question asks to you on what is the screening constant. So roughly just do the multiplication within a half minutes. Just write the electronic configuration. Okay, before examination you write electronic configuration roughly on a page. Okay, just fill up what atomic number asked to you, which element asked to you, and you do the you write the electronic configuration grouping the orbitals, then use the rules. So this way you can calculate the screening constant for any electron. So here we are going to discuss some examples. Okay, so first example is calculate screening constant for 3s electron of bromine, for 3s electron of bromine. आता इथं ब्रोमीनचा इलेक्ट्रॉन विचारलाय. So what is the first rule? Write the atomic number. So write the electronic configuration of bromine is 1s2, 2s2, 2p6, 3s2, 3p6, okay, 4s2, 3d10, 4p5. Okay, we also discussed this same example in the explanation part also. So then what next? Make a grouping. So for that you make a group here, 1s2, then for this 2s2, 2p6, then 3s2, 3p6. Okay, why we neglect this? Because here asked to 3s means third shell, so after that you neglect all the electrons, okay, you also neglect this. If 3p is asked, that time you consider because after 3 years there is a 3p. But when 3p is asked, you can consider 3 years, but for 3 years, when 3 years is asked, you neglect the 3p also. So you neglect all this part. Okay, so you asked to 3s electron means there are 2 electrons, out of that 1 electron asked to calculate their screen constant, means how many remaining? 1 electron remaining. So third rule, the remaining electron in ns and np, how many remaining? 1 electron is remaining. So for remaining electrons, 1 into 0.35, 1 into 0.35. So this is the your nth shell. So 2s is n minus 1. So you can also neglect this. It is a nth. Here is a n minus 1. Here is a n minus 2. Because when s and p electron asked to calculate, that time you consider n minus 1, n minus 2. But only when d electron is considered or f electron is considered, that time you only think remaining, you only write the value for remaining electrons with multiply by 0.35, and remaining all electrons you take a value 1.0. Okay, so for n minus 1, for n minus 1 electrons, how many there are? 8 electrons. So 8 into 0.85. For n minus 2 electrons, it is how many? There are 2. So 2 into 1.0. So total is 0.35. It is 6.8, 6.80. Here is a 2.0. So total is 5, 9.15. Total is 9.15 is your answer. Okay, so this way you can calculate the screening constant value for any electrons. Okay, so this is one of the example. If you have to ask the 3D, if you ask to 3D, then first of all you write the electronic configuration, then you make grouping up to this. इथपर्यंत ग्रुपिंग करायची, कारण हा विचारलाय. ओके, आता कसं ग्रुपिंग करणार? So here 1s2, then 2s2 2p6, then 3s2 3p6. आता बघा 4s हा 4 शेल मध्ये जरी 4s असेल पण 3d ही n-1 आहे, म्हणून 3d आधी असेल. 3d 10 आणि इकडे असेल 4s2 4p5. You have to ask 3d, so neglect this one, don't write. Okay, so how many? Third rule, the remaining electrons in nth shell, ns nd or nf. So how many electrons are remaining? 9 for each. What is the value? 0.35. So for remaining nd electrons, how much? It is 9 into 0.35. It is 9 into 0.35. Okay, so remaining all for each electron which are present in lower shell, you take a value 1.0. Okay, so for all remaining shell electrons, how, but you don't write directly 8 and 8 6 and 80 18 into 1, you write separately 8 into 1 plus 8 into 1 plus 2 into 1. So what is the total? You do the total here. Okay, 3.25. It is 3.25. Here is a 8 plus 8 plus 2, total 18. So here 18 plus 3.20, it is a 21.25. It is correct or not? Yes, it is correct. It is just, sorry, here is a 15. So this way you can calculate. I take another example. The another example, if you consider here, okay, we will take not a sodium. Sodium also is here. Okay, so this way you can calculate any one. So you try to solve all the questions which is given in book. In a tabulator form there is an example, each element is given, their electronic configuration is there, calculation also given. Try to understand it and you try to calculate it. Okay, and if you have any difficulty you ask me. So last point of today's lecture is, it is related to some, is it is a effective nuclear charge. Effective nuclear charge. Okay, so what is the effective nuclear charge? We already discussed the outer electron, and suppose here is the electron. It is the same as the earth and moon. Okay, so here this nucleus and electrons are attracted, always attracted, but their efficiency or effectiveness of attraction is depends on what present between them. Okay, we already discussed it, that between them there is other shells are present. That shell do the screening, do the screen. So this is a screening effect. Due to that the outer electron is somewhat shielded towards the nucleus. If it is more shielded, there is a decreases in attraction between the nucleus and outer electron. Okay, so this shielded is responsible how much attraction lie between these two. So that means, and this is the decrease in nuclear charge. Nuclear charge is positive, it is balanced the outside. But outside electron is lower attracted. म्हणजे बघा, जेवढा स्वतःमध्ये पॉझिटिव्ह चार्ज आहे तेवढा निगेटिव्ह चार्ज आउटसाइडला असतो, पण शेवटचा जो इलेक्ट्रॉन आहे हा तेवढं त्याला निगेटिव्हिटी देत नाहीये, निगेटिव्ह चार्ज, निगेटिव्ह फील्ड प्रोव्हाइड करत नाहीये. म्हणजे याचा जो न्यूक्लिअर चार्ज आहे तो जो बॅलन्स होत होता त्या आउटर, बघा लाईट आउटर साईडला जेवढे इलेक्ट्रॉन्स असतील अट्रॅक्टेड असेल तेवढा हा पॉझिटिव्ह जास्त होणार, पण याचं अट्रॅक्शन कमी झालंय. मीन्स हा जो न्यूक्लिअर चार्ज आहे जेवढा पॉझिटिव्हिटी स्वतःमध्ये आणतो न्यूक्लियस तो कमी होणार. सो दिस इज अ डिक्रीज इन न्यूक्लिअर चार्ज. दिस इज अ डिक्रीज इन न्यूक्लिअर चार्ज ड्यू टू स्क्रीनिंग इफेक्ट कॉल्ड ॲज इफेक्टिव्ह न्यूक्लिअर चार्ज. त्यालाच म्हणायचं इफेक्टिव्ह न्यूक्लिअर चार्ज. इट रिप्रेझेंटेड ॲज अ झेड इफेक्टिव्ह and it is calculated by z minus sigma. Z minus sigma. Here what is the sigma? Sigma is the screening constant, we already calculated. Z is the atomic number. Z is the atomic number. So we're going to solve this, how to calculate Z effective with the example. Okay, suppose you have the example sodium. You have the example of sodium. Okay, so you already know what is the atomic number of sodium, 11. So you first write electronic configuration. First you do the calculation of screening constant. So 1s2, 2s2, 2p6, 3s1. Okay, 3s1. Then you make a grouping here. So 1s2, 2s2, 2p6, then 3s1. Here is only one electron, means no remaining electrons in a 3s. So for nth, this is the nth, n minus 1, here is the n minus 2. So the no remaining electrons means here no value 0.35 is not required because the remaining electrons are not available. So it is n minus 1. How many electrons? Here how many electrons? 8. So 8 into 0.85 plus how many here? 2. 2 into 1.0. 2 into 1.0. Okay, so using this, it is a 6.8 plus 2.0, so total is 8.8. Total is 8.8. That means here sigma is equal to 8.8. So how to calculate Z effective? So Z effective is equal to Z minus sigma. Z is the atomic number, is 11 minus 8.8. So total is 1.2 is the Z effective. It is the effective nuclear charge. It is a decrease in nuclear charge due to screening effect. So this way you can solve the any example, you can take any example. First of all, once you calculate the screening constant, just use this formula. Suppose in a numerical options, okay, the screening constant value is given to you. Screening constant value is given to you. The question is like that. The sodium shows the screening constant 8.8. What is the effective nuclear charge? So you must know what is the atomic number of sodium. So 11 minus 8.8, it is 1.0. So this way you can calculate the effective nuclear charge. So this is all about the today's lecture. We will continue. The next point is atomic and ionic radii, some parameters, some trends of elements in a periodic table from top to bottom and left to right. But before listening next lecture, you all must have the periodic table. If you don't have the copy of periodic table, you can download the periodic table from Play Store. There is available, and using that periodic table you can know the information of element, all information about element when you just click on that element. So there are number of periodic tables are available. So this is all about today's lecture.